Hey everybody, Alex Miller at Capneon here. In a second, I'm going to show you an exciting demonstration of Ghost PII, but before I do, I'd like to talk a little bit about why am I making this video? Why am I showing you this techie stuff? This is a business website. What I'd ultimately like to convince you of is that there is this exciting new technology out there that can really help your business. And maybe you've noticed I put out two classes of videos. Over here, here's some weird situations and problems and meltdowns that we'd really like to fix. And then I make these videos also about Ghost PII. Part of the function of showing you the videos about Ghost PII is that, I run into some skepticism like I'm writing science fiction or that I'm talking about the year 2055. I personally hate the word futurist. I never wanted to be a futurist. I'm trying to be a right nowist. And what I'd like to convince you is this technology is here now. It's something you could realistically start using. And there are people like me that have been thinking about you and how to help you get moving. So if you're interested in that kind of help, absolutely contact me. But first, let me get into the demonstration a little bit and then we'll circle back. All right, so let me run this first of all, and I'm going to start pointing out some things about it. So this is a demonstration of a number of pretty standard operations you might be interested in on a 25,000 row data set. I want to point out there's pretty limited stuff that's totally unique to Ghost PII, and in particular, you've got to talk to our API, and then this is actually pulling down and encrypting a data set for us to play with right now. In just a second, it's going to show you. This is some information about a bunch of people's names, and the fantasy here is always, you wanted me to do some work on this data set, and there was a problem of some kind. It could have been about your corporate internal rules. I could be at an external firm. Maybe everybody is just real sketchy and you needed to bring out a new trick to calm them down. But one way or another, you wanted me to do some work on data and you didn't want to give me the data directly. You sent me the encrypted data, and the magic trick I'm trying to sell you on is you can do all your work on encrypted data just like you would before. So a second thing I'd like to point out is that a lot of this code is very similar to the kind of code you would use to do work with the regular plain text unencrypted data. And this is really the whole point. There's this big awful word, homomorphic encryption. The homomorphic really means I just need to know what I want to do if I had the plain text data. And then this technology is going to get it done for you on the ciphertext data, and you don't need to know all the details. Kind of silly on top of this is a real GitHub repo. It is in public. You could pull exactly this notebook down right now and test it. I am doing this on the smallest DigitalOcean box one can buy with just regular old Python. There's no GPUs. There's no special hardware. This is a pretty standard test you could get cooking in the cloud very quickly. I'd like to repeat two things here. This is a real thing that exists right now. It is not science fiction. It is science fact. And then once again, the point here is really not that you're getting sucked into doing some new thing that's going to punish your data analysts. The point is exactly that this technology can be very seamless. If you knew how to work with data, now you know how to work with encrypted data. And that is a very high-tech new magic trick. The technology is going to do the high-tech new part. There's no demand from you to understand a weird new thing if you already knew how to work with data. Now, moving on, people who are a little more informed about this kind of technology, there is a performance cost. It's always going to be a little bit slower. a little bit more memory intensive to work with encrypted data. But in the past 13 years, that penalty has come down by factors massive to where it's really not that bad. And I would say we have crossed a pretty crucial threshold. You know, if you have some really restrictive SLA you're barely meeting now, I get it. You can't put one more fancy widget in the tubes. You're gonna mess it up. But a whole lot of data work in real life and people's just everyday human flow, you know, you hit run, it takes some number of seconds, you go get a cup of coffee, you come back and it's done. And this technology has reached the point where it does fit reasonably into patterns of human attention. It's now true that you can hit run and get your cup of coffee like before, and like before, when you get back, it's done. And it might have taken slightly longer, but it might not take slightly longer in a way that affects your long-term productivity and the flow of your day. And so the real demonstration here is that I ran this script that I have all these different data science operations on a 25,000 row data set in the periods I've been talking to you right now. Inevitably, I have to edit these videos to get out all the cussing I make when I screw up. But this notebook runs in about 3 minutes. It's about 15 seconds to sell on average. And we do a lot of cool stuff. We start with this encrypted data set. I want to emphasize the scenario here is I would be working only with the encrypted data set. But for some of these operations, the whole point is that if you had the plain text or it comes up later, you got exactly the right answer, the same answer, like you really had the data. And you didn't actually have to see it to do that analysis if there was a problem with giving that data to whoever was really going to do the work. So we do some searching in here. We do some matching across some different lists. We do some different kinds of data analytics. We even go so far as we do this fancy clustering, comparing these names. This is something you could do for data quality, entity resolution type situations. And then, of course, you can compute median and mean. And in general, anything you can compute on plain text data, you can now compute on encrypted data. To emphasize a little further, if you're building an application and on the back end you need to check birthdays and add numbers, you can use this for that. And we'll show you some examples in the coming weeks. If you're trying to do machine learning and statistics, you can use this for that, and we'll show you some examples in coming weeks. A final point of emphasis, a lot of times when you're working with data, the real-time sync and getting the thing over the finish line is you have to convince different stakeholders to give you the data, assuage concerns about should you be allowed to have the data, is the data in the right place, is it on the right kind of box, test prod dev, outside the company, GDPR, blah, 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 blah. That's really what takes a long time on a data project. And this is a technology that, if those kinds of concerns holding you up are coming from cybersecurity and data privacy, you've got a lot more flexibility in this conversation. Do a good job for that stakeholder. We're going to protect your data. Everything's great. Give it to us so the project can move on. Would you rather solve that problem and get the shareholders on board, everybody confident the data is secure, you got the data? Everybody's out there now saying it's all about having the right data. Is it really a problem next to that problem that, when the data scientist was double checking the coffee machine, while the thing ran, that it took 25 seconds instead of 18 seconds? I don't think that's the case. And these numbers are coming down all the time at my own company and at other companies. Total recap, the tech is here now. There's a lot of value on the table for somebody to pick up. And I think it's something that's become pretty approachable, and you should think about approaching it. I can help you if you want.